So here we are with factoring and graphing to find zeros. So we're kind of getting the idea of why it is that we would have been factoring, and it turns out it's because we're going to find some zeros. So these are zeros for quadratic equations, so we'll notice that this square here is going to be prominent in all of our equations. So again, these are the notes, and the notes is just us going through problem number 2 from this assignment, and then the assignment will actually be the rest of them. So in number 2 here, we're going to factor first in order to find out what the zeros would be, and then we're going to actually graph it to confirm. So let's see, the first thing that I would look at, and this is why I chose to do this one, is a GCF. So if we go ahead and look through each of these, turns out a -1 is going to be one of the factors that would come out. Otherwise, we're going to have to do the factoring by grouping or with a box, and we don't really need to do that. So the leftovers after you divide everything by a -1 is just the opposite symbol. So instead of a -x squared, we have a positive. Instead of a positive 6x, we have a negative. And instead of a -8, we have a positive. All right, so then we need to go through and ask ourselves what's going to multiply to be 8, and then at the same time add to be -6. So of course we're going to end up using two negative numbers, but officially 1 and 8 could work, and then -1 and -8, but that would become -9, so we don't want that. Then we have 2 and 4, and -2 and -4. And after that, that's all of our factors. So the set that is going to add to be -6 is going to be these ones right here, which means that our factors, with a -1 way out front, are going to be x minus 2, and then also x minus 4. So this is your factored form. So if we fill it in over here, the factored form is a -1 out front, x minus 2, x minus 4. Remember that you can actually do these out of order because multiplication is commutative. So all you would need to do is put a -4 here in the first one instead of a -4 here, and then a -2 over here instead. But this is one of the answers. So moving on from that, we're actually going to find out what the zeros are. And zeros are actually known as X-intercepts. Okay, and so because these are X-intercepts, and if we look at the graph, this is the X-axis, we are actually going to end up, from this factored form, be able to actually find out what those X-intercepts are. If it's going to be on that axis, it does need to have a 0 for its Y value, because otherwise you're going to go up and then you won't be on the axis. And then it turns out that the opposite of the values that we got in our factors are going to be your X-intercepts. So for instance, I see a -2 here, which means that a +2 is going to be one of the zeros. And then a -4 is in the second one, and so that means that a +4 is going to be one of our terms. So +2, 0 is going to be one of our points on this graph, and then +4, 0 is also going to be a point on the graph. Taking a look at how we graph anything anyway, we can go ahead and plug in each of these numbers to figure out what the Y value is. So I'm not expecting you to know how to graph the rest of this or sketch it from what we know. So instead, we're going to plug in each of those numbers in for x up above. So our equation is f of x equals -x squared. And what else? Plus 6x minus 8. So if I want to start out and get f of -3, that means that I'm going to put a -3 in for each of these x values here. So I think the easiest way that I do it is by actually erasing the x and then going ahead and putting in a -3. Of course, since it's negative, go ahead and put parentheses around it so that you don't lose any of your symbols. So this first piece, when you simplify it, we've got -3 squared, which will make +9, but then there's a negative. So we've got a -9. The next piece is a -3 times a +6. So in that case, we're going to have minus, what's this number, 18, and then -8. It's a lot of negatives going on there. And so in that case, our first value, if we plug in a 3, is going to be negative 35. All right, so clearly we can't graph that one here, but we can kind of keep it in mind as we work through the rest of them. All right, then we're going to plug in a negative 2, so we don't need those numbers anymore. So if we plug in a negative 2, this first set is going to become a negative of negative 2 squared. So we're going to have a negative 4. And then to that we are going to subtract 12 and then subtract 8. So it looks like negative 24 as our next one. Again, in a 10 by 10 grid, we're not going to really be able to graph that in there. Oh, actually, I think this is a 15 by 15. Anyway. All right. Moving on. Now we're going to plug in a negative 1. So if we plug in a negative 1, good thing we went over order of operations, we have negative 1 squared, which is 1, and then we have to make it negative. Negative 1 times 6 is negative 6, and then negative 8. So it looks like we'll have negative 15, which I think means that I can graph that. So let's see, so apparently down here is negative 15. All right, so negative 1, negative 15 is our first piece there. Then if we plug in 0, oh yay, because zeros are so much easier. So, because basically what happens with a 0 is that everything ends up canceling that has a variable next to it. So notice that we'll have negative 0, or 0 plus 0 again, minus 8. So negative 8 is our 0 value. So let's see, 1, 2, 3, 4, 6, 7, 8. And those of you that are graphing at home and don't have graph paper, the best way to do this is to just make tick marks on an X and Y axis. So 1, 2, 3, 4, 7, 8. And then going over 1. Or in this case, actually at 0. So you can actually make it accurate, well, a little bit more accurate than anything else. All right, so then we're going to plug in a number 1. So this is a positive 1 this time. So it turns out 1 squared and then made negative is still negative 1, but then 6 times 1 is a 6, and then minus 8. So now we are just at, let's see, 6 and 9, so negative 3. So 1, negative 3, 1, 2, 3 right there. Now I assume putting in a 2, because we just said that that's one of our zeros, will result in a 0, but hey, let's go ahead and find out. So if we plug in a 2, that means that we're going to get a negative 2 squared, so negative 4. And then 2 times 6 is going to be plus 12, and then minus 8, and so that ends up being 0. So we do have that piece, so 2, 0. If I plug in a 3, this is probably going to be what we call our maximum. So I'm going to plug in a 3. So then it will start to come down after that. So plugging in f of 3, boop, boop, we're going to get a negative 9. But then we'll get 6 times 3, which is 18. So plus 18, and then minus 8. So it looks like positive 1. So over 3 up 1 is part of our graph. And what you're going to find out is that we do want to have as many points as we can on this 15 by 15 grid. So because this is actually going up and then coming back down, I actually know from the pattern that if I plug in a 4, since it centers around 1, I'm going to have a 0 here, and then a negative 3 here, and then technically a negative 8, because as you can see, this would be your center, and then all the rest of these kind of match up. All right, so I'll go ahead and graph the rest of those. All right, so then we again have this pattern, so I'm going to, I already graphed 4, 0, but then 5, negative 3 is here, And again, hopefully you can see that this is like a mirror. And then over here. So especially if I actually had the ability to graph on this iPad very nicely, either way, your parabola shape is what a quadratic has. So this is a parabola shape. All right. So after that, the next thing that you're going to be asked to do is take a look at this piece. Identify in the following for the functions. Okay, we need to look for each of these things. And of course, since we're doing notes, you don't necessarily need to search what these terms are. But the idea is that this was the one we graphed. And so from that, we should be able to find the y-intercept. So remember that the y-intercept is what's actually on the y-axis. So that is your y-intercept right there, which is going to be over nothing. So when we plugged in a 0, and then down -8. So over here, we can put 0, -8. The other kind of key idea of that is that it's actually just the last digit that's given as your constant. So it's all good. All right, then you have your axis of symmetry, and that actually comes from knowing what the vertex is. So going back to our previous idea, up here is your vertex. So that highest point that you have, or in fact the lowest point, whichever one the maximum is, you're going to end up having that as your vertex. So 3, 1 ends up being our vertex. And so because 3, 1 is our vertex, the axis of symmetry, meaning the thing that cuts it in half, is going to be at x equals 3. And that's a vertical line. X equals is a vertical line at x equals 3. So if we kind of put a mirror on this line, you can see that from one half to the other, it's the same going out. Just as we mentioned, the pattern kind of centers here, and then these are all the same after that. That's what the vertex is. All right, after that, they're asking you for if this vertex is a maximum or a minimum. So looking at this, is this a maximum or a minimum? And it is the maximum point of this graph. So the zeros, if we look back at this previous page, or even up here where we put them down, are 2, 0, and 4, 0. The next pieces are domain and range, and so if you don't remember that from Algebra 1, the domain are the possible x values. So taking a look at this graph, the x values are in fact going to go on to -infinity and forever, right? So because of that, we are going to say that the domain goes from -infinity for your x's, and then taking a look at the graph, how far to the right does it go? It's going to go forever. I mean, even though this thing is kind of like traveling slowly to the right, it will in fact, for the rest of time, go out into positive infinity. So that's why we're going to write infinity. You will always have these less than symbols here, okay, especially when you're dealing with infinity. And of course, since it's domain, you will always have x in the middle as well. Your range is going to be a little bit different because if we take a look at our image, how far down does this graph go? Well, it goes forever, right? That's what the arrows are for. So in that case, we're going to put here that it's going to have a minimum of forever. But then what is its maximum? Well, taking a look at the y value of our vertex, the y value is your maximum, and so we're going to say that it ends at and is actually equal to the number 1. This is what's going to happen in every quadratic that you have. The domain will always be -infinity to infinity. Promise, okay? And then it will always either have positive infinity and then a number, or negative infinity and a number. Okay, so it's either going to be one of these two ideas when it comes to the range. Just depends on if something is going to be a maximum or a minimum vertex. So depending on what this is, maximum means that it goes infinity in the negatives, but then it has this piece that it stops at, or it has a maximum. So taking a look at the assignment, the rest of it here, you are going to want to use a graphing calculator. So instead of graphing by hand, you could go ahead and in your graphing calculator, go to the y equals and put in these pieces. You will, for the x value, want to use the key that says xt theta n instead of the x as the alpha key. So if you use this as your x value, you should be able to type that in and get something that will work out that you can view. Of course, if you can't use the calculator that we have a link for on our overview of this class, you can go ahead and use Desmos if you must. All right, so there it is, the notes from factoring and finding zeros.